Hello there, everybody at home. Here's your warm-up. Go ahead, write the names of those segments in order, which one you think is the shortest to the longest. If you have to guess, that's fine. But if you think you know a way to check for sure, please do that. You're going to want to pause the video and do that because we are ready to go here. Alrighty, guys, here we go. While I'm snipping this out, does anybody think they know why these three segments have these three names? The names are actually related. Like if this was a game of connections, they would indeed be connected. Does anybody know what they might be?
Does that have something to do with the book?
Let me. Two of them are from books.
Yeah, Lightbringer, for some reason, it gives me Warrior Cat vibes.
Ah, so here's what they are, guys. Oh no, Truman.
And it's Gary.
Lightbringer, my brother, I feel like he let in a brand and
Oh, maybe that's not the one that I'm aware of. Yeah.
I thought Lightbringer was the name in Skyward.
Oh, could be, could be. The name of what though? The name of what? Did I hear? I think I heard somebody say it. These are all the names of fictional weapons. Gary, Lucille, and Lightbringer are a shotgun, a bat, and a sword, respectively. No, a shotgun, a bat, and a sword, respectively. So let's see here, guys. So let's see, Gary, Lucille, and Lightbringer. How many think that Gary's the longest? Gary's the longest. Ouch. How about Lucille? Okay, we got a few. Like two. How about Lightbringer? Oh, most. Okay. So did anybody think of a way to do this without just guessing? Because it's true. If I'm looking at it, I'm thinking Lightbringer looks like it's longer than Lucille, but how could you be sure? Like, how could you be sure? What do you think, LER? Okay. So you could rotate it, and then my only thing, like if you had parchment paper, that would be pretty great, because then you could take it here, and let's just make sure it's 2.34 inches still. 2.34 would put it right here. That's true. You could definitely do that, and then do that to all of them. Did someone think of another way that we might have done that? Let's see here. Well, Holland, go ahead. Yeah, these are. You could think of these as the hypotenuses. Hypoteni. Hypoteni. I hope so. Uh, of three right triangles. And if you do, you can use the Pythagorean theorem to find out their lengths. So for example, let's see here. Let's grab that from, that's going to be, oh, perfect. Holland, what are the leg lengths on Gary? 2. 2 and 7. So what would I do with those two numbers? 2 squared, 7 squared is 4 and 49. And then I get, oh, the 53, excuse me. And then we take the square root. Yeah. So here we go. Better get this thing out for sure today. You're going to want these for real, for real. Remember, guys, big smiles all the way through. Here we go. TI SmartView, TM emulator software for the TI-30X/TI-34 multi-view. Table A, you're not singing. TM calculators, Texas Instruments, validating software license. Dot, 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 dot. Dot. Table A! You guys blew it. There we go. Okay, now we're good. All right. There we go. Okay. So the square root of 53 is not surprisingly the square root of 53, which is about 7.28 units. So it's about 7.28 units. So I'm going to put that down over here for Gary. 7.28 units. Okay, how about Lucille? What are the leg lengths on Lucille? Let me see if I can get a little help from Bradley. What would the leg lengths be on Lucille? 5 and 4. And so what do I do with those? Which is... Okay. And then? Awesome. And you can already see the square root of 41 is going to be less than the square root of 53. But let's just see what that is, because I know I'd be curious.
I think
That's 53, excuse me. Square root of 41. 6.403. So that's about 6.403 units. And then finally, what about Lightbringer? We all thought Lightbringer was the longest. Let's see, Lincoln, what are the leg lengths on Lightbringer? 1 and 8. And so what do I do with those numbers? 1 squared plus 8 squared is 65. Take the square root of 65. And again, not too surprisingly, I don't think that reduces. Yeah, it's just as close as that. About 8.062. About 8.062 units. So now we know for sure that Gary was the middlest, Lucille was the shortest, and then Lightbringer was the longest, which I think probably makes sense based on what weapons they are. Yeah, go ahead.
Gary the shotgun.
Uh-huh. Sure, absolutely. And that could work, right? That could work. But now we know exactly how long they are. I'm going to tell you guys right now, that was a whole day of Math 8.
Oh wow.
Is using a right triangle to find these line segments. So there we go. You did it. All right. It is the 131st day of school, guys. Since the decimal expansion of 1 over 131 is 130. Whoa, excuse me. Digits repeated. I didn't finish that because I was in a rush. It is a full reptend prime. No, I have to look it up. But a full reptend prime is to say, like, let's see, can someone give me just a prime number? 3. So I can tell you that 3 is not a full reptend prime because 3 is, as a decimal, is just how many digits repeated forever? Just 1, right? It's just 3 repeated forever. If it was a full reptend prime, it would be 2 digits repeated forever. Okay? 7, I think, is a full reptend prime because I believe it is 6 digits repeated forever. Happy Teenage Mutant Ninja Turtles Day! Yay! Guys, on my feed, like when I open up, you know how when you open up a new tab on like your phone and it's like, here's stuff we think you'll be interested in. And then like, I don't know about you, I don't click on them ever because I don't want them to know anything more about me. But you guys know what I'm talking about?
Yeah.
There was a thing about like, yo, check out this Teenage Mutant Ninja Turtles article. And I was like, number 1, you know me. Number 2, I'm not clicking on it. Number 3, why are there 6 of them? I do not know. There was like one who had a yellow, and then what? I don't know. Like, because I know obviously the red one is. You guys know? Raphael. Blue. Leonardo. Purple. Everybody's favorite orange. Mikey. Yeah, Mikey. And if you want to know who the black bandanaed Teenage Mutant Ninja Turtle is, you have to read a incredibly violent Teenage Mutant Ninja Turtles comic. He is one of them. But anyway, let's see here. Underneath, oh no, we got to do the essential questions. What's our first essential question? And I would love to get that from Miss Gracie.
Okay, so our first essential question is, how can I use the Pythagorean theorem to find the distance between 2 points?
Go ahead and write that down. How can I use the Pythagorean theorem to find the distance between 2 points? All right. Our Jeopardy is Ireland. The flag of Ireland contains the color white, along with these 2 less common flag colors. The correct answer is green and orange. Green and orange. Someone was thinking green and red. Red is by far the most common flag color there is. And then white is second. Mm-hmm. Yep, it is. And also the United States, France, it's a ton of them. And then, oh no, you're right, because I was thinking green and, red and blue. Anyway, good luck charms. That is indeed a 4-leaf clover. Hooray! Okay. Underneath all this, guys, well, actually, if you have one of our math notebooks that's graph paper, you're set. You don't have to do anything. But if you don't, send someone from your table to table I to grab a big sheet of graph paper for everybody, because you're going to need it for today's. You're going to need it for today. You're going to, yeah. Find out how many you need. Go grab one for everybody. Bring them on back. No, wait a minute. That's not that Cora. This Cora. Okay. All right. Can I get you guys back up here in 5, 4, 3, 2, 1? Guys, if you'll take your graph paper and hold it up and down like a portrait, like this, so it's tall. We're gonna draw a coordinate plane on there that is gonna be a little familiar. You guys are gonna remember having done this before, but it's only in quadrant 1, and it's gonna go 12 on the x-axis and 31 on the y. So we need to go 31. I'll count by fives. And guys, you're going to want to make it so that every box counts as 1. Every box counts as 1. Otherwise, this is going to be really tricky to do. 1, 2, 3. And put the little ticks in between. So it should look something like this. A million gazoontites. Gazoontites all around. Okay. There we go. And once you get that drawn, you can put a title for today. Today's topic is birthday distance. Birthday distance. Okay. Go ahead and draw that for me. Take another 20 seconds. So we're going to do these first few the long way, and then we're going to see if we can't find a shortcut to make this easier on ourselves. By the way, I really appreciate what I'm seeing out there. Just about everybody's drawing this, working on this, doing all the right stuff. I think you guys do deserve a point. Hooray! And while you guys finish, someone was asking what scoreboard game level 5. I completely forgot to mention this on the day that we came back for fourth quarter. Scoreboard game level 5 works exactly the same as all the other scoreboards, except if you win by 4, guys, what happens when you win by 4? What are some things that happen when you win by 4? You get 4 here, you get an accent card the next day, you get 4 points towards the class goal there. But here's what's going to happen, guys. The number of points you win by are going to be actually equal to the number of accent cards I have to put in the deck. Which means if you win by 4, I don't put 1 accent card in. I'm going to put in 4. Can they mix and match? Yes, they can. That can absolutely happen. So be on the lookout for that. And then the other thing is, guys, is that if ever our team score, our class score goes above 7, we get all the benefits of being the winners, okay? You get all the benefits of being the winners, except you don't get to pick a new accent card. Okay, let's do it. I need some birthdays. Let's see if I can get some help out there. Gracie, I just called on you for the essential question. Why don't I get your birthday?
November 22nd.
Okay, so Gracie, what's your favorite color?
Pink.
Pink. So we're going to do Gracie at November 22nd.
Yep. My
Oh.
birthday makes for a really crappy password because it's 11.
11, 22. Oh, that's true. So 1122 is going to go right here. There's Gracie right there. And who else's birthday do I need? Carol, when's your birthday? Oh, I don't want to do that one right now. Even though that is my birthday, and I think that's cool. I don't want to do that one right now. You guys might. How many of us think, but they see why I don't want to do that one right now, November 14th? What do you think, Truman? Yeah, same month, and that's going to be too easy, right? We're going to make it a little harder on ourselves. Zoe, how about you? September 2nd. I thought for a second you said September 22nd, and I was like, oh no, I don't want that one either. But Zoe, what's your favorite color? Purple. So we're going to go Gracie and Zoe. And you said September 2nd. So 9, 2 was right here. There's Zoe. So just like we found with Lightbringer, Gary, and Lucille, when I say teach, I want you guys to say, okay, can you use the Pythagorean theorem to find the length of the line segment that connects Zoe and Gracie's birthday? See what you guys can do and teach! What's that? Oh, certainly. I'll get those out for you in just a second. Yeah, if you feel the need for rulers, I'll get them put on table I here in just a moment. I know that new winter brought some new diseases. Now everyone's feeling newly sick. Yeah, if you want a ruler, I got them at table I. Pardon. Okay. Give you a second to get those. Okay. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Let's see here. Carol, what were the leg lengths of this right triangle? 20 and 2. And then what do I do with those numbers? Yeah, so 20 squared plus 2 squared is, I believe, 404, is it not? Okay. And then what do I do with that number? Yeah, take the square root of 404, which that actually does reduce. I think it's 2 root 101. Yeah, 2 root 101. So it's exactly 2 square roots of 101. But again, depending on what we're trying to accomplish with it, we might want that approximation about 20.1. If I round that to the nearest thousandth, that's actually really interesting. If I round that to the nearest thousandth, that's only 20.1, because the 7 makes this 9 round up to a 10, which rounds that 9 up to a 10, which puts the 1 here. So we're not going to put 20.100, we're just going to put 20.1. That is still rounded to the nearest thousandth. Okay? Beautiful. Now let's get your birthday going. Carol, what's your favorite color? What was that? Pink. There we go. And then your birthday was November 14th. Much like the coolest people I know. And mine. All the cool folks. So Carol is at 11,14. And then Thomas, what's your favorite color? Blue. And when is your birthday? 7,22. So that would be July 22nd, right here. So there's Thomas. So let's find the length of the segment that connects Thomas's birthday to Carol's. So what are the dimensions of the right triangle that gets made when we connect Thomas and Carol's birthdays? Give it a try, and here we go. Teach! Okay. All right. Can I get you guys back up here in 5, 4, 3, 2, 1? Claire, what are the dimensions of this right triangle? What was it? 8 and 4? That's 8. Okay, and then what do I do with those numbers? Yeah, 4 squared plus 8 squared is 16 plus 64, which is 80. Okay, and what do I do with that number? Yeah, the square root of 80, which I think is that? Is that 4? What is that? 4 square roots of 10? 4 square roots of 5. Missed one. Okay, 4 square roots of 5, which is about, let's see here, 4 square roots of 5 is around 8.944, about 8.944 units. How many of us were able to get 8.944 units for that? Now, here's what I want to do. We're going to do it again, and we're still going to put it on here. But how many of you are starting to notice that there is a shortcut to all this? How many of you are starting to notice that there is a shortcut to all this? So I want you to try the shortcut and see if it works, but then also check on your graph to see if they line up. Claire, what's your favorite color? Green. So Claire. And when's your birthday? June 16th, 6 comma 16. 6 comma 16 goes right here. We're going to put C sub 1 for Claire because we already have a C. And then let's see here, the cards love table G. Stephen, what's your favorite color? Blue. And so Stephen is 1 comma 17. So 1 comma 17 puts us right here. There's S. And what do you get if you, it's kind of a sea green color, I think, if you mix those, right? What is the distance between those 2 points? And can you think of a way to come up with the legs of that right triangle without having to do any counting? Give it a try and let's see how it goes. Teach. Hooray for color coordination. I love color coordination. I know a bunch, actually. I've got 2 doors down neighbor. His name is Steve. And then my wife's brother's name is Steve. Your name is Steve.
Steve from now on. You're gonna be called Steve from now on.
I don't think that's up to us.
There's a gazillion Sams
Okay.
and Addies and a gazillion Spiders.
Can I get you guys back up here in 5, 4, 3, 2, 1? LED, what are the dimensions of that right triangle? What was it? 5 and 1. And did you get that by counting?
I did it, like, I subtracted 6 from
Yeah.
1 from 6.
That's 6 minus 1. That would be the 5, right? Because that's the change in x. And then
And then I got 1 from
17 minus 6, and that's 1. Very good. And then what'd you do with those numbers?
I squared them and added that together.
To 26.
And then
I don't think that reduces. 5 point, oh, well, let's see. Let's take a look. Sometimes those roundings are really tricky. The square root of 26, 5.0, I would call it 5.099. If I'm rounding it to the nearest thousandth, since the 0 follows that 9, I call it 5.099. Does this remind anybody of any other process that we've done a whole lot of? Anybody remember doing this earlier? Do you guys remember doing this with slope? Where you have your change in y over change in x? This is very similar. The only difference now is that your change in y is the leg of a right triangle and your change in x is the leg of a right triangle. Here's the other thing I wanted you to notice. Claire went 6 minus 1 and then 17 minus 6. Would that be okay if we were doing the slope? Yes or no? No, it wouldn't, because if we went 6 minus 1, we would have to do 16 minus 17 if we were doing the slope. And it turns out it's okay if it's negative, because even if it is, like if you got 5 and negative 1, when you square these numbers, it doesn't matter, because negative 1 times negative 1 is positive 1, so it'd still be 25 plus 1. Let's do the crazy one. Who's got a birthday that's late in the month, early in the year? Late in the month, early in the year. Ellie, oh no, Sophia, excuse me.
May 31st.
I'll do it, May 31st. So 5, 31, that's Sophia. And who's got a birthday that's late in the year, early in the month? Late in the year, early in the month. John.
December 6th.
John, love it. December 6th. 12, 6. Without counting, because that would be a huge pain in the butt, what is the distance between these 2 points? Give it a try and teach. Yay. Even the square root part? Oh, okay. Yeah, I'll do that too, though, for sure. So how can I do it without graphing them? Yeah, let's do that, because we're not going to worry about the graph now, because the next ones, you definitely don't want to put them on a graph. Beautiful. Love that, for sure. Yeah. Yeah. We want to do it without a graph and then see how it goes with it. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Hoi Bing, what did you get as the leg lengths of this right triangle? Great. So we have 25 and 7 because that was 31 minus 6, 12 minus 5. Love that. What do I do with those numbers? Square them. You know, you would think I knew 25 squared. I don't. 625 plus 49. Let's see here. 625 plus 49 is 674. And what do I do with that, Huibing? Yeah, take the square root of it. Oh, look at that. It doesn't reduce at all, but that's okay. About 25.962. So the square root of, what was it, 674, which is approximately 25.962.
When I was little, I thought approximately meant exactly.
Oh, that's no good. How many of us got that, guys? Or see how Huibing got that and aren't too worried? Okay, now, guys, this process is really helpful when there are things we super don't want to graph, like this. Huibing, when's your birthday? Huibing at negative 12, comma 18. And let's see here. Can I get a birthday? This one's going to come from Jaden. When's your birthday? Excellent. So we're going to make that 3, comma negative 30. How many of you would be super excited to put these on a graph and count all that? There you go. You may do so on your own time. For us, though, can we use that shortcut to make our lives a whole lot easier? Talk to each other about how and teach. Take another 45 seconds. What did I do? I'm innocent. Huh?
I'm great at yelling.
Oh, I'm so sorry. I didn't hear. I'm so sorry. I thought it was a 3. Whatever you did is fine. Whatever you did is fine. I misheard him. I'm sorry. Okay, can I get you guys back up here in 5, 4, 3, 2, 1. Truman, what are the leg lengths of the right triangle here? 48 and 15. Beautiful. And notice that those numbers went up. Because negative 30 minus 18 would give us negative 48. But I actually heard, Sophia, I think I heard over there talking about it's really the absolute distance, right? Because we're not worried about negatives. Now, you can leave them negative if you want to, because when you square it, it'll still turn out positive. But if you just think of it as the absolute value of the distance, like the difference, that's great. And then 3 minus negative 12 should be 15. So we put it through the old song and dance, 48 squared plus 15 squared, which I'm sure is a terrifyingly huge number. 48 squared plus 15 squared. And then what do we do with that? Well, what do we do with that? Who was I talking to? Oh, wait, no, it wasn't. What was I? What on earth? Oh, there we go. I was talking to Truman. Sorry, Truman. What am I going to do with that number? Yeah. And just so you know, It won't tell you the exact on that. It'll just give you 50.289. It's about 50, so it's about 50.289 units. How many of us by raise of hand either got that or see how we got that and aren't too alarmed? Okay. So, a student was asking me, because we were doing the volume of regular n-gonal prisms, like a pentagonal prism, for example, and they were like, Mr. Petersen, can't you just give me the formula for this? I'm going to tell you, like, maybe you guys have picked up on this already. I'm not a huge fan of formulas. Like, formulas are not my favorite thing. I'm so glad you guys are catching up, because there was one year where I was like, guys, formulas are not my favorite thing. And someone goes, well, yeah, they're for babies. But that's not what I mean. But formulas are not my favorite thing, because in my mind, do you guys understand how this works? Do you guys feel, if someone asked, how do you find the distance between 2 points, do you think you could describe the entire process to them?
Yeah.
Yeah. You talk about right triangles, about distances, change in x, change in y, and it's a beautiful thing to talk about those things. But because other people are going to put you on the hook for it, there is something called the distance formula that you need to be aware of. Got a pencil?
Absolutely.
The distance d between 2 points x sub 1, y sub 1, and x sub 2, y sub 2 is ... d equals parentheses x2 minus x1 all squared plus y2 minus y1 all squared, and then you have to take the square root of that thing. I mean, yeah. How many of you guys can see that that is true? That's what we're doing, right? Now, how many of you guys would rather actually use this formula and just plug in the numbers and be good with it? That's okay. How many of us would rather just take it one step at a time? Subtract, square, add, square root. That's how I am too, because I think it's actually leaves you a lot less room for mistakes. Like, I'm imagining typing that into my calculator and completely blowing it, right? Like just putting a parentheses wrong. But you do need to know that the distance formula exists. It is important, but for now, I really prefer just using the geometry here, right? Like, what's the change in y? What's the change in x? Those are the legs of a right triangle. I square them both. I add them. I take the square root. I'm done. Oh, Shrilan, go ahead. Sure, calculators are weird that way, right? So let's do it, guys. If you want to use the formula, use the formula. If you want to not use the formula, don't use the formula. But will you find the distance between these 2 points? Negative 2 comma negative 75 and 2 comma 18. However you want to find that is great. How would you find the distance of the segment that connects negative 2 comma negative 75 and 2 comma 18? Give it a try and teach. Ooh. What's that? That's fine. That's okay. Hey, you do whatever you got to do. Like, if you do like the subtraction squared, and then square root it, that's fine. I can live with that. But when you get to calculus, the distance formula is important. You do need to know it.
So we're doing absolute value, right? The
Yeah.
matter.
Yeah, because it doesn't matter if it's positive or if it's negative, because even if it's negative, when I square it, a negative times a negative will always be positive. So in my mind, I actually think it's easier. It's a much harder equation to write down if you actually put the absolute values in there, but it's easier just to think of it as absolute values. It's just like, yeah, let's just do the positives. One last thing our calculator can do to screw it up. Yay. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Sophia, what were the leg length, or how did you do this? Did you use the slope? Did you guys? Hold on, let me hear Sophia. Did you use the distance formula, or did you just say here's the legs, here's the squares? Great. What were the legs?
So I first did -2 -2, and that
That's -4.
-4, and I just think of it as 4.
Sure thing.
And then I did the same thing, -75
Love it. So squared them and added them. Yes. Mm-hmm. Beautiful. About 93.086. 93.086. Which makes sense. If you imagine this being like 4 this way and then like 93 this way, like you could imagine the hypotenuse, of course, is longer than the leg, but would the hypotenuse be a whole lot longer than the leg? Not really. So that's not too surprising. Awesome. You guys did great today. I think you guys super deserve a point. I think we're going to pop you up over here for that. Hold on just a second. Hold on just. Oh, indeed. I'll investigate. Let's see here. There is no self-assessment today, guys. I just want you to sleep on this, and I wanted to give you a bit of a break there. Did yesterday's self-assessment make sense to you guys?